Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 80. So in today's lesson, we're going to begin adding some tests for our leaderboard. So these will be some unit testing. So it's been a little while since we've done that, so we're going to do it here today. So we'll just go ahead and get started. So the very first thing I'm going to do is I'm going to come over here and I'm going to right click on the solution and go to Add New Project. So my project this time is going to be a I guess we'll search for it. I was going to look through, but let's just search XUnit. There, XUnit test project. So we'll use that. I think this will be 2.9. This one will be XUnit 3. I'm just going to go with the standard one for now. I don't know. Everyone may not have that one, so we'll just go with this one for now, but may bump up to that one in a future lesson. All right, so I'm just going to call this I'm just going to call it unit test. We could come up with a better name, but I think that'll do for our purposes here. All right. So the one class we're going to start unit testing is the leaderboard here. So we'll play around with some of it first. So I'm going to right click on this and I'm going to move to tab group to the right. Now we'll have a unit test. So let's add a new file here. We will add new, let's call it leaderboard manager tests. We'll use that as my naming style here. Let's delete unit tests because we don't need that. All right. So first thing first, we need to identify what we want to test here. It may be a little hard to test right now. We may need to make this testable. It might be the first thing we do. Um, yeah, this may not be easy to work with right now. So let's just do this. We'll just do a couple simple tests. So we'll start with a fact, public, void. All right, so the name of my test, I'm going to use the style add player. Yeah, this may be harder to test than I was planning. So add player adds new player when not duplicated. So we don't have any count. That's what I'm thinking is we should actually have a count here. Let's do that. Public int count. There's our count. That should work and everything should be in range. So let's do that. So let's do our player. Oh, we're going to need to make a change. So first things first, we right click here. If we go to Did an add there. Add project reference. We're going to reference our multiplayer game leaderboard, so that way we can use their classes over in the test project. So now, if we do player, now I can find it. So test player equals new 1 1 player 1. They have a score 1. All right. So what we will do now is we will do leaderboard manager system under test equals new system under test dot add player test player. So now, here. So our pattern here is arrange, act, and assert. So the idea here is we set up our test, we do whatever action we're testing, and then we assert that that action happened. So what we'll do here, let's do this. We'll do assert dot equals 0, assert dot count. So there was no count originally. Now we'll assert that it equals 1. So assert that it added. Let's do player retrieved equals assert dot find player with player ID of 1. So let's pull that out. Const int test player ID equals 1. We'll do that down here. It's just saying it can be nullable. So now assert dot not null retrieved assert dot equals test player comma retrieved. I think that'll work since it's a record. There we go. I think that'll work. So let's see if that works. So what's this saying? Test classes must be public. Okay. So let's see if that works. So to run a test, I was hoping we would get a visualization here. Let's rebuild and let's see if we get it after that. We do not. What I was expecting was a little play test or something here, so let's do it this way. Let's I'll do it from here. No. Let's go here, let's do this, and let's run test. And there, it pulls up our test explorer. And there we go, there's a little annotation. One test passed, so you can see it turn green. So what that says there is that we met this condition. So these conditions worked. 261 milliseconds seems pretty long. Yeah, there we go. Okay, so it says that worked. So we added a player. Let's do that same thing. Retrieved by name. So here we'll do const name string test player name equals player 1. So instead of retrieved here by that, we'll do test player name, and that one should also be green because it should be almost the exact same case. And it ran. Okay. So there's just 2 tests. So let's do let's do a third here. Let's do a duplicate test. Fact public void add player does not add when adding a duplicate player. All right, so let's do something similar here. So in our case, duplicate player is a player with the same ID, I believe, right? Yeah. So it's going to throw. That may be what I don't want it to do. Throws when adding. So I have some comments here about what I might want this to do instead. So this may be the time to actually evaluate that. But here, let's do player test player equals new. Here, let's just copy this. And let's use the name in two places here. So player 1. All right. Player duplicate player equals new test ID. Player 2. They got a score of 2. We'll copy this line. All right. Now we'll perform our acts here. Assert equals 1 count. All right, so here's the important one. So add player, duplicate player. Let's see what happens. So I suspect this is going to throw, and I think I don't want to do that. Yes, it fails. System invalid operation. So that's a perfectly valid way to handle that. I think that's actually... So you should use exceptions for things that are actually exceptional. I don't think adding a duplicate player feels exceptional to me. And I think I said that originally as well. To do, consider making or adding a try add to return true or false maybe, or maybe result. I think I like that better. So rather than throwing an exception on an invalid add, instead we return false maybe. So let's do that. So we will add let's do a separate one. Public void add player, public bool add player, player. So problem there is that the name actually matches. So already defines a member with the same parameters. So that's the method signature. So we'll have to do something different. What I'm going to do different is just going to say try add. All right. So what it's going to do is we're going to do this exact same thing here. But now, if not result, return false. Else, then we do this exact same thing, and we return true. And that's our triad. So now we're not throwing an exception. So what we can do here is let's swap these out and let's see if we get the same behavior for these two. I'm going to add a try, 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 and try. Alright, so now let's see what happens. Wanting to run them all from here, so it took away the test runner. I don't want to auto hide. Alright, so now they succeeded, but there's not really anything here, so we would want to finish this logic. So now let's say assert dot equals 1 sub dot count. So there it didn't add a duplicate, so let's check that that actually worked. And it did. Okay. So that's roughly what we were wanting. So triad seems to work as we expect. Although it says there's 0 references, there's definitely some references. So let's go check this one. So here, handle add player. We'll just swap this to triad as well. So let's do this. Bool result equals this dot triad. So now if result, so if we added successfully, if we didn't add successfully, that's when we'll error. So then we'll just do the same error here. And we will say the player ID already exists. Now we don't need this catch block. And we're done. So I think that will do the exact same logic. So let's see where we also use add here. Generate players. We'll just do triad. Okay. And I guess we can say we don't care. So there. I believe we changed that, and now we can just straight up delete this. And there. Now we've got a little bit safer. Say safer. The other one was safe, but it's going to throw an exception, and you have to catch the exception. This one, we don't care. So let's do this. To do analysis. So let's do add a non-duplicated player. A player is duplicated if IDs already exist. I don't think we need. So what I was doing there, I was going to add a doesn't even show it, does it? It doesn't even show it, so yeah. So I'm just going to get rid of players, and we'll do returns true if the player was successfully added, and false otherwise. Here I'm gonna there. Does it tell us that one? Yeah. So I don't think I need a parameter there. You could put it there, but I think the player is pretty self-evident from the rest of it. What I'm here, I'm big O analysis. So what I'm wanting to do here is do a little bit of thought on what the complexity here of these inserts and triads are. There, I believe that gets us our little adjustment there, and now we've got some tests. We test duplicate. Let's test adding multiple players. So let's do a fact. So let's do this one as a theory. Theory, and then the next line is inline data. So a theory lets us pass in the information. So we will do 1. Public void, add player, adds, supports, adding multiple players when not duplicated. Okay. So let's do this. So that needs to take int count. All right. So now let's do this. We'll do leaderboard manager soot equals new for int I equals 0, I less than count, I plus plus. So now we'll just do soot.triad player, new player. We will do i.toString. That'll get us a bunch of players. And now assert dot equals zeros or count soot dot count. So I think that will be enough. We could do some verification, make sure they're not duplicates. We may do that, but I may make a few adjustments before we do that. But there's us a 1, so that's the exact same case we've got above. Let's do 10, 100, and 1,000 just for good measure. All right, let's see if this one runs. I wish it would take me over here. And they do. All right, so I think that's sort of where the kind of testing I was thinking for add. So let's check. Let's check remove player. So remove player needs all the logic of add. So let's do this. We'll do fact public void remove player returns null when there are no players. Let's make sure that's true. So dot remove player we don't actually care, so player result equals that. Assert dot result assert dot null result. I think that will get us a test, so let's see if that works. Test passed. Is there some way to get this pinned? There we go. Take up a little bit of our screen real estate, but I like that better than having to keep going back and forth. All right, so remove there worked. So the other case for remove that it should be a null is remove player returns null when the ID does not exist. So this is basically the same one, but let's add the actual player to the list. So we'll do soot.try add player, new player 1 1 1. So now there's a player there, but their ID is not 0, so that should be return null as well. And it did. So good. So the next case is public void remove player returns the removed player when they exist. So let's do this. So we will do here. We will do this one. Let's do this also. Let's assert dot equals count of 1. Assert dot equals count of 0. So now we have a player. Assert dot equals 1. Assert dot count. So there is a player. So now we will try to remove them. So dot remove player, passing in 1. So let's const int test player ID equals 1. Player result equals that. So now let's do some testing. Assert dot not null result. So the result's not null. Assert dot equals 0. Assert dot count. So the count's good. Let's do them in the other order. So now we'll assert that the account's good. Assert that which one's equivalent? Let me check it just a second. I think the equivalent may actually be what I'm actually after there. That shouldn't be soot though. That should be new player test ID 1 1. Player expected equals new player. Like that. Let's see if that works. It did. Let's make sure it works. If I mess it up though, let's say their name wasn't that. Okay, yeah, okay, so equivalent may be what I'm after there. Let's see if equals fails on that. Okay, yeah, so equivalent may actually be the one I'm actually after in that case. The equals does work. Yeah, okay, good. let's take this advice. Okay, so there's us a remove when they exist. So there's some other things we could do now as well. Technically, we can make sure that we can't we can't update their score or anything afterwards. That would also be probably a good thing to do. Make sure they don't result in the ranking list, maybe. Let's do that. Let's do fact public void remove player causes player to not show up in rankings. So something like that. So we'll just copy all this. Let's add a second player. Two. So now list of player rankings equals soup.get rankings. So now what we're going to assume is all of them are still the case. So we're not testing that though. So let's do assert.notEmpty rankings assert.equivalent assert dot does not contain. There we go. That's what I'm after. Does not contain expected in rankings. So I think that should do. And here we don't actually use the player we removed, so we could just do a discard. Let's see if that one works. It did not. Oh, yeah. Count is now 2. Okay, that one makes sense. There. And instead of remove player, nah, we'll keep that for remove. That one's a little more nuanced. I think that's roughly our remove functionality. Yeah, I believe that's roughly where we want to get with it. Okay, yeah, we'll hold off on that. So we test here if we at least do a little test here that it actually deleted, but I think that'll be good. I think that's good enough. Let's add some for find player. Fact public void. We sort of did actually. Wait a minute. Okay. Find player by ID. Returns null when ID is not found. So we'll do that test. Find player by ID 0. Player result equals that. So we will do assert.null result. That should be the case. We'll do the same thing for name. When name is not found, test. Okay, good. Control R, Control T. Okay, that works. Alright, so that's roughly the testing I would consider there, because we could separate them out, and a lot of people would recommend you separate them out instead of doing the find player here. I see that logic. Maybe you make these equivalent, but I see that logic, but at the same time, I'm not sure if I 100% agree. So I see it both ways. Like, there's such deep interaction between find player and add player here. If there was more logic here in find player, maybe I would agree a little more, but I think for what I'm doing here, I think this makes sense to me, just to have it tested there. Update score. Update score is a little trickier. So let's start with the exception. Fact public void update score throws invalid operation exception when player ID does not exist. Let's see. Assert. Let's see. How do I have to remember how to do an exception test here? Throws invalid operation exception. So update score of 1. Does that not work? Oh. Update their score to 1. I think this throws here, it does return an exception, right? Yeah. Now assert dot equals player with const int ID equals 1. ID was not found. Was not found. And that needs to be ex.message. So that should get us there, that test. There we go. So otherwise it updates the score. So what we'd want there is that definitely we want to check that the player return has an updated score. So let's do that one first. Public void update score returns the updated player score. Let's do const int original score equals 1, const int updated score equals 42, const int ID equals 1, so leaderboard manager, so equals new. Let's do this as well. Player, test player equals new, passing in ID, test player, and original score. So dot try add test player, and we don't care about the return value. I guess we could check if it's true or not, I guess. Do we actually do that up here? Wait a minute. We should at least do that up here, actually. True result. Same thing here. And I'm going to leave this one. So we'll do that one's true. Reset it here, and now insert false result like that. So here we don't care about the value though, so there. Now let's do player updated player equals dot update scores of ID to updated score. So now let's make sure that worked. So assert dot equal updated score. Now let's do it like this. Let's do player expected equals new ID test player updated score. We'll do it like that. And that'll be equivalent. Expected updated player. So we'll do it like that. Let's also do a find. Assert dot equivalent expected find find player, and we'll pass in ID. Let's do it with name as well. Being overly done here, but just for the sake of our example, string name equals test player. I would press Control D there and double select, but this is not Visual Studio Code, so that actually doesn't work. Assert dot equivalent expected dot find player name assert dot equivalent expected dot get get rankings dot first. That's a method. And finally, assert dot equivalent expected assert dot get top players 1. The top player. That's a list dot first. So all those should all return the same value. So let's see if they do. Being overly pedantic, they do not. Oh yeah. So there is something. So update score doesn't set that score, it increments. So that's one thing to keep in mind there. So maybe update score shouldn't do that. Maybe it should just set the score actually. Nah, nah. So what I'm thinking is you would have their current score and then you would add they got 17 points. So yeah, I think that's actually makes sense. So we'll keep it as is for now then. Still failed. Alright, we may actually have to see where that one failed at actually. Get more info. On 182. So it failed here on the first one. So the expected 41 got 42. Oh, yeah. Plus 1. Now let's do it the other way. So let's set that to 42. Update score 41. We'll do it like that. And there it went green. Okay, I think that's sort of gets us the most of the way there. So what I would like to do in the next time, so we're basically out of time. So what I'd like to do next time is look into how we actually test some of this other stuff like tree or heap. So I don't necessarily think this is a great example, but I'm thinking we go into mocking next time. So I don't remember if we did that or not in the previous testing, but basically it gives you a way to do a fake implementation of something, and then you can use that to test it. And what we're going to use it for is I'm trying to think of the right terminology. What we're going to use it for is to see if we called max heap peak or tree traverse in order. I'm wanting to do that kind of check there. So that's a different kind of test. So when you do tests, there's different names for them. I'm trying to remember which one's which. I want to say that one might be a mock, but I could be wrong on that one. So the difference in on one of them returns a value, one of them doesn't. So I might try to go look that up and try to remember for the next time. But that's what I'm thinking we'll do next, is though actually try to test go get in a little deeper on the testing here and actually check the different calls here. So that's what mocking will get us, and we'll have to do some adjustments here to the actual class to do that. But I'm leaning toward that being our next one, and we'll get to see some other features like getting adding references to our project. So that may be the next step. So yeah, we'll call it here with this though. So this has been a good start to testing. There's still some more stuff I want to test in here, and being able to mock it will make some of that easier. So that'll be the next step. So we'll call it there. So thanks for watching, and have a wonderful rest of your day.